Okay, in this lesson, we're going to be solving nonlinear systems equations, and actually the method is exactly the same. A nonlinear system of equations is a system in which at least one is not linear. So we might have parabolas, we might have circles, we might have ellipses, hyperbolas, all those other different types of equations we've been looking at. There can be one solution, multiple solutions, no real solutions, or infinitely many to a system of nonlinear, just as before. So let's go ahead and graph this. Solve each equation, system of equations by graphing. The bottom, notice, is a linear equation, so let's go ahead and graph it with our methods we used before. And it was simply a line with a slope of 2 and a y-intercept of 8, so go up to 8 and then rise 2, run 1. Now our parabola, y equals x squared plus 8x plus 13. You can use other methods that we've learned. You could use negative b over 2a if you would like to find the vertex of this thing. Let's do that first. Negative b would be negative 8 over 2 times a would be 2. So my vertex is located at negative 4 comma something. Plug that in, and that gives you your y value. Negative 4 squared is 16. 8 times negative 4 is negative 32. 16 minus 32 plus 13, and that gives me negative 3. So my vertex of my parabola is located at negative 1, 2, 3, 4, 1, 2, 3. So there's the vertex. It cups up because it's a positive. And from there, what you can simply do is just plug in values on each side. Let's plug in a negative 3. And you actually get a negative 2. So negative 1, 2, 3, negative 2. And since this vertex also represents our line of symmetry, that means I also have a point over here. We can plug in negative 2, and we get 1. So negative 1, 2, positive 1. So that means I'm going to have another point across my axis of symmetry right here. And you can continue doing that, or you can look for patterns. Notice that we went up 1 over 1, up 3 over 1. So up 1, 3. Next up, I believe we're going to go up 5 and over 1. So 1, 2, 3, 4, 5 and over 1 would be right here. And do the same thing over here. And there is your parabola. But again, we're interested in simply solving the system, and that's just going to be where do these two graphs cross. So my two solutions would be right here and right here, or excuse me, right here. And those 2 points would be negative 5, negative 2, and negative 1, 6. We can always check those by plugging it into both of these equations and making sure it does check out. Okay, number 2, we have a circle, and then we have a sideways parabola. So the circle, that's pretty easy to graph. This center has not been shifted, so the center is at 0, 0. So here's the center. And then our radius squared is 25. So we're going to go 5 in every direction. 5, 1, 2, 3, 4, 5 up, 5 down, 1, 2, 3, 4, 5, right and left. And then simply connect your dots. And there's your circle. Now for y squared equals 8x minus 8, you can do that a couple of different ways. If you would like to solve it for y, you can do y is equal to plus and minus to get rid of that squared, the square root of 8x minus 8, 8x minus 8. And then you can start plugging them in. The other way of doing it is you could get it in your other form. You can move the 8 over and divide by 8, and you're going to get x is equal to 1/8 y squared plus 1. You can graph it either way. I'm going to use this method, and I'm going to plug in values that that I know is going to give me something I can take the square root of. Like when I plug in 1. Plugging in 1 gives me plus and minus the square root of 0. When I plug in 1, the square root of 0 is 0, and I believe that's actually going to be my vertex there. When I plug in, let's say, another value, maybe 3, that gives me the square root of 16, which would be a positive 4 and a negative 4. So when I plug in 3, 1, 2, 3, I get 1, 2, 3, positive 4, and I get a negative 4. 1, 2, 3, 4. And I actually graphed those in the wrong place. Those should be graphed right here and right here. And those are going to be my intersection points. Here's going to be my parabola. And my 2 points of intersection will be at 3, 4. and at 3, -4. That's my solutions. Number 3, again, I have a parabola and I have a line. So let's start out with our parabola. Y equals -2x squared plus 12x minus 15. And I've actually taken, and another method that we can use here is we could write this thing in transformation form, and we can find our vertex right here, which would be at 3, 3. Plot your point. This thing's going to cup down from there. Find a couple more points, and you can do so by plugging values in. Like you could plug in 2 maybe, and you're going to get 1. So another point on your graph would be located at 2, 1. So that means that here's another one on your graph. You could plug in 0. That would be, or excuse me, plug in 1, and you're going to get -5. So that's going to be located at 1, 1, 2, 3, 4, 5, and you would have another point right here. So there would be your parabola. Let's go ahead and connect my dots. And now let's go to our second equation. I'm going to use if you use x and y intercepts here, it's going to be tough because your x-intercept is going to be -24, so that's not going to fit on our graph. So let's go ahead and get this in y equals mx plus b form. It's going to be -4y equals -1x minus 24. Divide everything by -4, and that gives me y equals 1/4 x plus 6. So we're going to cross at 1, 2, 3, 4, 5, 6. We're going to rise 1 and run 1, 2, 3, 4. Connect our dots, and here's our line. And these two graphs do not cross anywhere. So therefore, there are no solutions. As we stated in the introduction, there doesn't have to be any intersection points. Okay, number 4. Let's do another one. We have a radical function, and radical functions look something like this. And then we have a linear function. Again, the radical function, what I like to do is plug in values that I know would be easy to plug in, such as if I plug in -6, that gives me the square root of 0, which is something I can take the square root of. So when I plug in -6, I get 1. So my first point is -1, 2, 3, 4, 5, 6, 1 right there. Let's plug in a value, maybe, let's see, I know the square root of 1, so let's plug in a -5, and that would give me a square root of 1 inside of here. When you plug in -5, you get 3. So -5, 3 is located there. Other things, I know the square root of 4. So when I plug a -2 in, that gives me the square root of 4. Plugging in a -2 gives me 5. So that'd be located at -1, 2, 1, 2, 3, 4, 5. And then maybe a value like 3. That gives me the square root of 9. That'd be 2 times 3 is 6, plus 1 is 7. So at 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. I believe that'll be enough of a graph. Let's go ahead and connect our dots, and here's my graph. And now let's work on the line. Now I can use x and y intercepts here very easily. Plugging in 0 for x gives me an 8 for y. This is a linear function. Plugging in 0 for y gives me a 24 for x. So we're not going to be able to use our x and y intercepts because that's not going to fit on my graph. But I can get that in slope-intercept form, and this is what it'll look like. And there's your line. So the two graphs does have an intersection point right here, so your solution is going to be 3, 7. Okay, let's now solve them algebraically because, again, unless you're using Desmos or something, it's kind of hard to solve these sometimes with graphs. So let's go ahead and show you how to solve them. And again, it's going to be the exact same substitution and elimination. So substitution, solve one of the two equations for y or x, and then you simply plug it into the other one. So here we have y is equal to 1 minus x. So go to your other equation, and in the place of y, substitute in 1 minus x. So you now have 1 minus x equals x squared plus x minus 2. Solve the resulting equation. That gives you, this is quadratic, so we got to move everything to the same side. That'd be x squared plus 2x minus 3 is equal to 0. We factor. Two sets of parentheses, x times itself gives you x squared. Add multiplies will be a positive 3 and a negative 1. So therefore, x is either equal to -3 or x is equal to positive 1. You have two different solutions. We now go back one at a time and we plug those solutions in to find our y values. I would definitely plug them into the second equation. It's a little bit easier. When x is -3, that gives you 1 minus -3, which is 4. When x is 1, 1 minus 1 is 0. So therefore, your two intersection points are -3, 4, and 1, 0. That would be a parabola intersecting a line there. Okay, next one, you have two parabolas intersecting. Y equals something, y equals something. Well, since y is equal to this, go back up here where you have a y and replace it with that. That gives you 2x squared plus 5x minus 4 equals x squared plus 3x minus 5. It is quadratic, so move everything to the same side. Subtract x squared gives you 1x squared. Subtract 3x gives you 2x. Add 5 gives you 1. When you solve that by factoring, this is a perfect square, so that's going to factor into x plus 1 times itself. Take the plus and minus square root, gives you x plus 1 is 0, so x equals -1. So there's only one solution here. We then go back and plug in that -1 into either equation. For our x's, that gives me 1 minus 3 minus 5, which is -7. So x is -1, y is -7, so that would be our intersection point. And you can already tell that algebraic is so much quicker than graphing. Next up, we have a circle and a line. Again, solve it with either substitution or elimination. It'd be hard to solve this with elimination, so let's go back to substitution. So take your second equation, solve it for either x or y. I'm going to move my 3x over, and that gives me 2y equals -3x, divide by 2, and gives you y equals -3 halves x. So take your other equation, and in the place of y, let's put that -3 halves x. So there's your new equation. To square -3 halves x, make sure you square everything. That's going to be x squared plus. Square the negative, square the 3, square the 2, square the x. That's going to be 9/4 x squared equals 52. This is going to be 1x squared will be 4 over 4 with the common denominator. That's going to be 13 over 4 x squared equals 52. To get rid of 13 over 4, multiply the other side by 4 over 13. Those cross cancel, leaves you with 1 and 4, so that gives you x squared is 16. That worked out nice and neat, so therefore x is equal to plus and minus 4. Don't forget both. So there's your two solutions, is a 4 and a -4. Again, you can plug it into either place, but the second equation is going to be so much easier, either one of these. So when x is 4, plug it in. That's going to be -3 halves times 4, which is -6. When x is -4, that's going to be a +6. So there's your 2 points of intersection. Number 8. Now here you can use possibly elimination. And normally I wouldn't here, but I do want to show you how to do it. Normally I would use substitution. Y squared is this, so I would take out y squared and put that in. You don't have to substitute for y. You can, since it says y squared, we'll take out y squared and put that in. However, let's line everything up and show you how to do these with elimination. So I'm going to rewrite this whole thing. My first equation I'll leave, y squared equals 2x plus 13. Actually, I'm going to leave a space here, and I'll show you why in just a second. And the second equation is going to be y squared equals, and I'm going to put my x squared stuff first, and it doesn't combine with anything up there. So -x squared, a -6x, and a +1. So I've got everything lined up. It doesn't matter where it's at as long as everything lines up with its matching term, including y squareds with y squareds, x squareds with any x squareds, x's with any x's. Okay, constants with constants. So in order to get my y squares to eliminate, I'm going to take my second equation. Now I'm not going to rewrite it. I'm going to multiply everything by -1. And this is what happens. It'll change that positive to a negative. Now when I add my two equations together, my y squareds are gone. Now you have to be careful because you need all the y's, including all y squareds, including all y's as well. Here you would not have been able to have eliminated your x's because you don't have any x squareds to eliminate with the x squareds down bottom. So now you have 0 equals positive x squared, add them together, that'd be a positive 8x and a positive 12. So that's how elimination works. Everything's got to cancel. Factor, that's going to be x plus 2 and x plus 6. So therefore, x is either -2 or x is -6. Let's go back and plug it in. Best place is going to be probably here. So let me go ahead and write that down. Y squared is 2x plus 13. And you're going to have multiple answers here. So when x is -2, that gives you y squared is 9. So that's going to be y is positive or -3. So when x is -2, y is either positive 3 or it could be a -3. So there's 2 points of intersection. What about when x is 6? Let's go back and clean it up again. When x is 6, that gives me -12 plus 13, which is 1. Y squared is 1, so that means that y is positive or -1. So I have a solution of -6, 1, and a solution of -6, -1. So there's actually 4 different answers there. Now let's take a look at this graph and try to figure out why are there 4 different answers. And here are the 2 graphs that I get. I actually have a parabola and a circle, and you do see those exact same 4 points of intersection. There, 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 and there. Those are the 4 solutions because they cross at 4 different places. Okay, next problem, number 9. We have 2 parabolas here, and again, we can solve this with substitution or elimination. You've got to be careful because if you want to use elimination, you're trying to eliminate the x's. You've got to multiply something by the first equation that would get these and these to cancel. And I don't think that's going to be possible. Now, you could eliminate your y's, but why not just go ahead and substitute? Since y is equal to this, plug it in for y. So that gives you -3x squared minus 12x minus 5 is equal to x squared minus 6x plus 10. It's quadratic, so let's move everything to the same side. I'm going to move it all to the right, so we have positive x squared. So that'd be 4x squared. When you add 12, that'd be a positive 6x. When you add 5, that'd be plus 15. So therefore, you have a bottoms-up factoring problem. So let's go ahead and solve that by bottoms-up factoring. Move the 4 to, or excuse me, slip and slide. So that'd be x squared plus 6x plus 60. Let's factor that. That's going to be, let's see, adds to give you 6, multiplies to give you 60, and there is nothing. So therefore, what does that tell me? This does not factor. And since it does not factor, that means we're going to have to use our quadratic formula. And again, I like to start out with your discriminant, b squared minus 4ac, and that's going to equal 36 minus 4 times 4 times 15, which is 240. And I already notice a problem here. 36 minus 240 is a -204. That's a negative. That's the stuff under the radical. So therefore, you have imaginary solutions here. What does that mean? You can't, with the real number system, you can't have imaginary answers. So therefore, before I go any further, there's no solutions here. There's not going to be any real place where these cross. However, if you would want to go ahead and find your 2 imaginary solutions, you could go ahead and plug that in and work this problem on out. But you can really stop when we're looking for real solutions and just say there's no solutions to this system. Number 10. Here again, you've got 9x squared plus 16y squared. It looks like you have maybe an ellipse, or yes, an ellipse, since the A and C are different, and then you have a hyperbola. So let's try to figure out where this ellipse and this hyperbola cross. Now, this is one case where we can use elimination very easily. Let's leave our first equation as is, 9x squared plus 16y squared equals 289, but we can very easily get these y's to cancel. Let's multiply our second equation by 16. That gives me 16x squared minus 16y squared equals 21 times 16, which is 336. Now we have these things lined up and our y squareds are gone. So that gives me 25x squared is equal to 289 and 336, which is 625. Divide both sides by 25, and that gives you 25. So since x squared is 25, that means that x is equal to positive and -5. Now to find the y's that go along with it, again, you can plug it into either one. This one's probably the simplest. So let's take, and I'm going to use a different color here. Let's find our first solution, which is 5 comma something first. So let's plug in 5, and that gives you into this equation, gives you 25 minus y squared is 21. I'm going to flip-flop my 21 and y squared, and that gives me y squared is equal to 4. So y is positive and -2. So therefore, when x is 5, then y is 2, or y could be negative 2. Now our second solution, what about when x is negative 5? When you go to plug it in, guess what? This is the same. Everything works out to be identical. You still have 25 minus y squared is 21. So when x is negative 5, y is 2, or y could also be negative 2. And again, the reason it ended up like this was you did have a hyperbola and an ellipse, so that's the reason it is going to cross at 4 different places.